welcome to Know Physics with me. Hope all are doing good. Yes, so we have started with Physics CBSE Class 10 Chapter 10 Light, Reflection and Refraction, and we are in our 9th session. So previously we have covered 8 different sessions, and first part of the session is almost complete, and we are into the second part of the session, and 2 or 3 videos related to refraction we have done, and in this session we are going to learn about lenses, okay, where lens is used and what type of lens we are going to learn in this session, in this lesson, and then what are all the rules for a ray diagram or rules to form images, okay, using lenses. So those who have learned about mirrors, lens will be very easy, except 1 or 2 changes. It is quite similar to that of mirrors, okay. So for those who are clear or thorough with mirrors, you will find lens very easy, okay. Yes. So before detailing getting into the topic, let us learn about the term, okay. So we are all familiar with the term lens, right? So where do we generally use lens most predominantly? Spectacles, right? Yes. So those who wear spectacles are very familiar with this term lens. Yes, we do use lens to see objects distinctly and clearly. Yes or no? Yes. So our lens is nothing but, we do have lens inside our eyes, okay, naturally. So that we learn in the next chapter, the human eye and the colorful world. So for now, we will understand what is lens, what are all the types of lens, and which one is involved in our syllabus. And then we will go with rules for drawing ray diagram using lenses, and then image formation using ray diagram for lenses, okay. Yes. So what is a lens? A lens is again a transparent glass material, just like a mirror. It is also a glass material, okay. And the condition is, here it has 2 surfaces. So let me give an example. So here it has 2 surfaces. In mirror we have only one surface, in which one side is a reflecting side and the other side is polished, yes or no. Here we have 2 surfaces, in which at least one surface should be spherical. Only then we call it as a lens, okay. So I will give you a few lens types, okay. So in our 10th syllabus, we learn only about the first and last one, and this is one additional type of lens, okay. So this is a convex lens, this is a planar convex lens, and this is concave lens, okay. So any one surface should be spherical. So here both the surfaces are spherical. Here one is plane and another is spherical. Here also both are spherical. Clear? So we call this as double convex lens. Okay. And here it is double concave lens. And we say this as planar convex lens. So we will learn the first and third one, that is where both the surfaces are spherical, okay. So double convex lens can be simply called as convex lens, and double concave lens can be simply called as concave lens. Both are one and the same, okay. Yes. So here it is bulging outwards. Here it is bulging inwards. Yes or no? When compared to mirror, a lens, if you see, there will be some thickness at the center and it is thin at the edges. In some cases, it would be thin at the center and thick at the edges. It depends on whether it is concave or convex lens. In convex lens, your center part would be, how it will be? Your center part would be thin and your outer surfaces will be bulging. Whereas in concave, the center part will be thick and outer surfaces will be thin. At the edges it will be thick. You understand? So here it is bulging inwards. Here it is bulging outwards. So a double convex lens can be simply called as convex lens, and double concave lens can be simply called as concave lens. And we also call this as converging lens. And this as diverging lens. So just like the mirror, in mirror if you see, you say concave mirror as converging mirror and convex mirror as diverging mirror. Yes or no? So lens and mirror has just opposite process. In convex lens we say it as converging lens and concave lens we say it as diverging lens. That is the light that pass parallel after reflection. And the important point that I have to tell is, in mirrors we saw the phenomenon of reflection, right? Mirrors. Whereas for lens we undergo the process of refraction. That is bending of light takes place. Okay, so what is happening is, you have a lens and light rays passing through the lens. After refraction, what will happen? It actually, refraction is happening, right? Because change in medium. So bending takes place. So what will happen after bending? If the light converges, we say it is a convex lens and converging lens. If it diverges, we say it is a concave lens and diverging lens. Are you clear? Yes. Now just like mirrors, we will see some of the important terms that are related to lens. Okay. So it is quite similar to that of mirror except one or two. Okay. So the first thing that we do is, we have something called pole in mirror. So instead of pole, we use the term optic center in lens. Okay. Instead of pole, we have optic center, which is denoted by the letter O. So lens, let us consider it to be double convex lens and double concave lens. Okay. So here O is nothing but the center point of the reflecting surfaces. Yes or no? Here instead of that, we will say the center point of the two lenses which are part of spheres. Okay. That is nothing but called as the optic center. So the optic center is here. O. Okay, understood? This is convex lens and this is concave lens. Next, what we will draw, we will have a principal, wait, before principal axis, we have center of curvature, right? So here, if you see, you have two center of curvature, okay, because it is part of two different spheres. So you have a center here and a center here, right? Whereas in mirror, you do have only one center, which is the center of a single sphere, right? Here we have two surfaces, which is a part of two different spheres. So we do have two center of curvature. Similarly, here also we do have two center of curvature. So in order to differentiate both, let us call it as C1 and C2. Okay? Yes. Now a line joining both the center of curvature along with the optic center. I am very sorry, my line is not correct. So a line, an imaginary line joining both the center of curvature and the optic center is nothing but called as principal axis. Yes or no? Yes. Then we do have focus. So how will you draw focus? What is a focus? Where parallel rays after reflection meet is called focus in case of mirror. Where parallel rays meet after refraction is nothing but the focus in case of lens. Okay. So focus always lies between optic center and center of curvature. Okay. So let us name it as F1 and F2. Okay, in order to avoid this center of curvature confusion, instead of C1 and C2, I can call it as 2F1 and 2F2. Yes or no? So, how I am saying it as 2F1 and 2F2 is, you know, what distance from optic center to focus it is there, the same value will be there between F1 and C1. Yes or no? We have seen previously. Yes or no? In mirror, we have seen the same concept. The radius of curvature, yes, the distance between the optic center and the focus will be same, equal to the focus and the center of curvature. So instead of that, can I write it as 2F1? It is twice that of F1. So I am renaming it as C1 and C2. Instead of C1 and C2, I am renaming it as 2F1 and 2F2. Similarly here 2F1, 2F2. And here we have focus. Clear? So these are all the important terms. Then focal length as usual. What is focal length? The distance between the optic center and the principal focus is called the focal length. And what else? Aperture. Here aperture is the same diameter of the spherical surfaces. You understand? Spherical refracting surfaces is nothing but the aperture. That is, it is the one which decides how much amount of light should enter the lens. Okay. So if the size of this is small, tiny one, then the amount of light passing through the lens is less. If it is wider or big in size, then the amount of light passing through is much larger. You understand? So that is nothing but called as aperture. Okay. Then what else? So these are all the terms. So instead of C1 and C2, we have 2F1 and 2F2. And we do have two focal lengths F1 and F2. Then principal axis is same as that of mirror. Then we have aperture. Then focal length. Clear? So these are quite similar to that of mirror except the terms. Instead of pole we have optic center here, and instead of C1 and C2 we replace it by 2F1 and F2. Okay. Remaining all are same. And there we have single focus, single center of curvature. Here we have two center of curvatures and two focus because we have two surfaces. You understand? There reflection is happening, here refraction is happening. Okay. Yes. So just like mirrors, we do have rules for drawing ray diagrams in case of lens also. So you can comparatively learn. Okay. So whatever you have learned for mirrors, almost the same applies for lenses except few changes. Okay. We'll see what it is. So the first rule will be like this. What is the first rule for mirror? The same rule is for here also. So a ray parallel to the principal axis after reflection passes through the focus in case of concave mirror and appears to pass through focus in the case of convex mirror, right? So you remember whatever you are writing for concave mirror, that will apply for convex lens, and whatever you wrote for convex mirror will apply for concave lens. Okay, just the opposite process. Okay. Yes. So for lens, first let us draw the lens. So this is a double convex lens and this is double concave lens. Okay. So this is our principal axis, this is optic center, and we have two focus, and instead of center of curvature we will write it as 2F2. Similarly here 2F1. The same applies here. So F2, 2F2, F1 and 2F1. Okay. Yes. So what is the first diagram? First rule, a ray parallel to the principal axis. This is our incident ray, right? So it is parallel to the principal axis. In mirror we saw after reflection. Here after refraction we will learn. Okay. So a ray parallel to the principal axis after refraction passes through focus. Okay. So here you might think it should pass through F1. But it won't happen. Instead it will pass through F2. It is because refraction means there should be change in medium, right? Yes. So here change in medium is from here to here. So it will pass through the focus F2. So this is nothing but a refracted ray. So a ray parallel to the principal axis after refraction passes through the focus. So this is the first rule for convex lens. And how about concave lens? So see, if you take a ray from this direction, it will pass through F1. Okay. So since we are considering only from one direction, we will draw like this. Okay. Similarly, a ray parallel to the principal axis after refraction, so appears to pass through focus. Okay. Here it is not a real image. Instead, what you obtain here is a virtual image. It is not a real image. So it will pass through the focus on the same side. You understand? So this is the rule. A ray parallel to the principal axis after refraction passes through the focus on the other side. A ray parallel to the principal axis after refraction appears to pass through focus on the same side. Clear? Yes. So this is our first rule. Now we'll go with the second rule. Okay. What was the second rule we learned in mirrors? Just the vice versa of the first rule, right? A ray passing through the focus after reflection appears parallel to the principal axis, right? That was the second rule. So the same applies here. So this is okay. So as usual, note the points, okay? Sorry. So kindly adjust my diagrams. It is of rough diagrams, okay? So a ray passing through focus. So let us draw a ray passing through focus. And it should touch the, okay? It should touch the lens. Only then what will happen? Refraction takes place. So simply don't draw a ray passing through focus and touching somewhere here. It should pass through the lens. Then after passing through the lens, what will happen? Refraction takes place, and after refraction it appears parallel to the principal axis. Did you understand? A ray passing through the focus after refraction appears parallel to the principal axis. Okay. So for concave lens, let us see how to draw. So a ray appearing to meet at focus, okay? After refraction appears parallel to the principal axis. So this is how you have to draw the ray diagram. You understood? A ray passing through the focus after refraction passes through the principal, lies parallel to the principal axis, and a ray appearing to come from the focus after refraction appears parallel to the principal axis. So this is how you have to draw the ray diagram for the second law. Okay, and second rule. We'll go with the third rule, and we do have only 3 rules in case of lens, whereas we have 4 rules for mirrors. Yes or no? Third rule alone is different. First and second rule is same as that of mirror. In mirror we use the term reflection. In lens we use the term refraction. And whatever we write for convex, we will write for concave here. Whatever we write for concave mirror, we write for convex lens. That is the only difference. Okay? Yes. So rule 3 is very easy rule, and there we saw the rule 3 as a ray passing through the center of curvature is reflected back along the same path. Yes, here the rule is a ray passing through the optic center. A ray passing through the optic center goes undeviated, which means there is no deviation here. So the same rule applies, and the same kind of ray diagram goes for both. A ray passing through optic center have exact diagrams, okay? And the arrow is like the same arrow, okay? Check for this. Whereas in passing through center of curvature, it is reflected back along the same path, right? Yes. Here it goes undeviated. There is a reason why there is no refraction taking place. It is because here both the points acts like parallel rays, okay? So it just acts like glass slab. In glass slab we saw, right? So what will happen in glass slab? There is no angle of deviation in glass slab, yes? Why? Because we get a parallel rays, right? And they are equal and opposite. The same kind is obtained when the light rays passes through the optic center. So that is the reason why it goes undeviated, or it goes without any deviation. So a ray of light passing through the optic center after refraction goes undeviated. So it is the same for both the lenses. Okay. So these are the 3 rules that you have to follow while drawing ray diagrams. Okay. Yes. So I hope you are all clear with what is a lens and where all we use lens. A small picture. Okay. We have seen where we use lens, and then types of lenses, and about converging and diverging lens we saw, and some of the important terms related to lens we learned, and then what are all the rules for drawing ray diagram in case of lens we saw. We made a comparative study, right? For mirrors how we draw, and for lens how we will draw. What are all the rules? That all we saw in the session. In next session we will draw image formation by lens. Okay. Yes. So the refraction is the phenomenon happening in case of lens, whereas reflection is the phenomenon happening in the case of mirror. So I hope you are all clear with this session. Okay, what all we covered in this session. So if you find it useful, do share it with your friends and do subscribe my channel. So thank you for watching this video. Thank you for all the support given. Keep supporting. So thank you.